Okay, so we're going to be solving trig equations using a calculator. We're going to be using the N5-4, so make sure you have that ready to go. And I'm going to show you, we can graph using the N5-4, or we can graph using our what we know about graphing. So I'm going to start off with what we know about graphing, and then we'll take it to the N5-4. Okay, so here, when we're graphing to solve, what we're going to do is we're going to treat each side of the equation as a separate function. So let's see here. Okay, so on our N5-4s at f1 of x, we will type 2.5 sine x. And at f2 of x, we will type -1. Now for our calculators here, we're going to graph this. -1 will be the horizontal line through -1. Okay, and apologies for the lack of a straight line, but my technology is not that good. Okay, so then sine x of 2.5 tells us we did not shift off the from the origin. So sine, remember, is starts at 0, 0. At pi, it'll be at 0. And at 2 pi, it's at 0. The 2.5 is our amplitude, so we count up 2.5. So we'll be here. And then halfway between, so this is at 3 pi over 2, we'll be at -2.5. Okay? Now, so we can see that the places where these intersect would be our solutions. But it's a little tricky to figure out what they are based on this graph. So we're going to use graphing on our N5-4s. So on our N5-4s, we're going to select graph. Okay. And before we start graphing, I'd like us to set up our window to match the grid on our paper. So if you'll go ahead and select menu and then window, so 4, and we're going to do number 1 for the window we have. Okay, on our grid, we were going to start, it has a line at -pi over 2, so we're going to type -pi divided by 2. Okay, and then the x max would have been at 2 pi. Okay, and then we're going to count by pi over 2. Each of the lines on our graph was pi over 2 distance apart. So we're going to change our scale to pi divided by 2. Okay, and then our y minimum was at -5. Our y max was at +5. And then our scale was 1. Okay, so looks similar to this. Of course, your calculator has put it in decimals. All right. The other thing is our instructions are to round to 3 decimal places. So we're going to go ahead and change that as well. So we're going to do menu 8 for settings, and then display digits. We would like to change that to fixed 3, because that'll give us the 3 decimal places. We're in radians. Okay, so that's good. So make default. Okay, and the cool thing is once you do this, your calculator is now set for the rest of the time you work, as long as you don't hit Doc B. Hit Doc B, it's going to reset. So this would be one time where you want to just delete the equations each time. Okay, so our first equation was 2.5 sine x. So we just type that, 2.5 trig function, enter, and then inside the parentheses, x. Okay, hit enter. Okay. And then you want to hit tab. And at f of 2, you're going to type -1 and enter. Okay. You notice this is very much like the graph we just created on our paper. So that's excellent. And now what we wanted to know is, where do these intersect, right? So menu, 6 to analyze, 4 for intersection. Okay, so we're going to get our dotted lines to the left of the intersection point and then to the right. And if you can't read it, remember you can grab it and move it. So you can see that that is 3.553 is our x value. So one of our solutions to 2.5 sine x equaling -1 is 3.553. Okay, so now we want the other point of intersection. So we would do menu 6, 4 again. And then we set our dotted line to either side. Okay, and again, if you can't quite read it, you can go ahead and grab it and move it up, and that's going to be 5.872. Okay, so we go back to our paper, and we would write that x equals 3.553. And x equals 5.872. Okay. All right, let's take a look at another. Okay, we're going to set up the same. Left side will go in with our f of 1 of x. And 3 will be our f2 of x. Okay, so if we wanted to graph it by hand, come here. Hopefully you'll be able to do a better job with your straight edge and pencil and paper than I'm doing right now, but there's f of 2 of x. Okay, and then for cosine, this is not shifted left or right. We don't have an h or a k, but we do have a period change and we have an amplitude change. Okay, so remember that the period would be 2 pi divided by the 1/2, so that's going to actually be a period of 4 pi. So what that's going to mean is we're not going to get a full cycle of this cosine graph on our paper. Okay, so it's a positive cosine graph, so we're with an amplitude of 4, we're going to start here at 4. Okay, at 2 pi, we're halfway. So when we're halfway on the cosine graph, we are at minimum. Okay, and then halfway between there, we're at 0. So we've got to kind of, right. All right, so this is our one and only point of intersection on our period of 0 to 2 pi. Okay, so to find that one out exactly, we're going to go back over to our Inspire, and what we'd like to do here is go ahead and clear our graph from before. So I'm going to hit tab, I'm going to go up, I'm going to delete that, and we said that would be 3 now, so I'm going to hit enter there. Okay, and then I'm going to hit tab again, go up to F1, and I'm going to change that to 4 cosine 1/2 x. And that 1/2 needs to be inside the parentheses. So we're going to go 1 divided by 2 x. Okay, and we hit enter. And it looks a lot like the picture we just drew. Okay, so we want to find that point of intersection. So again, menu 6, number 4. We're going to set our dotted line to either side, and we get 1.445. Okay, so our answer for this, since there's only one point of intersection on that whole time, is going to be x equals 1.44.